my 1458 value, which is right here, because UN, we're trying to find the number of terms. So they don't give us a specific number, we're just trying to find the total number. But because we know the end value, the last value of this sequence, we can put that as a replacement for our UN. So then we'll just fill in the rest with our other values. So 8192 would be our U1 value because it's the first value of our sequence. Then we would have, open parentheses, our ratio, which is 3/4 to the n minus 1. So this is where it kind of gets a little tricky. You can use a logarithm here. You can, because of the fact that this is an exponential calculation. But because this is going to have an exponent, that's what I mean. So 3/4 is going to be lifted to n minus 1 power, whatever that is. And you can use a log to find the n value, but what we're just going to do now is we're going to solve it as is. So what we're going to do is basically take this 3/4, but first divide 8192 both sides. So by this 2. When we divide 1458 by 8192, we get 729 over 4096. And from that, this is where we have to see to get our n value. So this is where, again, it's kind of a little bit tricky, but what we can do is we basically can see 729 and 4096 and get that to be 6. So we would have 6 as our n value. So we would input 6, so 3 to the power of 6 and 4 to the power of 6. And what we would then do is that we know that 6 would be not only, I'm sorry if I said n value, I mean n minus 1 value. So it would be our n minus 1 value because we could figure out that n would be 7. So sorry if I said 6 equals n. It does not. We would know first, all we have to find is what we already found, which would be the 6. We already have the minus 1. And what do we know that equals 6 by subtracting 1? It would be 7. So n equals 7. So let's move on to what is a series. A series is an operation of adding infinitely many quantities. So basically in this, you're going to be finding out ways to do summations on certain objectives and values. And let's start off with arithmetic. I meant to put that first, but an arithmetic sequence is an operation in which has a constant difference between each given value and oh, sorry, not sequence, series. And the sum of the terms of a sequence is called a series. So this is where we kind of get this relationship amongst series and sequence. So again, this is one of the major important things. I'm going to write that down right here. The sum of a sequence is a series. And this is a major thing that you need to know because it helps you better understand both of them equally. So the sum of the terms of an arithmetic sequence is called an arithmetic series. And for a geometric sequence, it would kind of be along those same lines, but just a little bit different because you're not doing the common difference, you have a common ratio. But anyhow, a geometric series is an operational it's an operation, not operational. Is an operation which has a constant ratio, not ratio, between each given value. And basically that's what I just said. Arithmetic sequence has a difference. Geometric series has a given ratio. A ratio between each given value. So arithmetic series, not sequence, and the geometric series. So the formulas for each, you have for arithmetic series, you have Sn equals n over 2, then open parentheses u1 plus un, and that's an arithmetic series formula. And then for geometric, forgot to put this right here. Geometric is Sn equals U1, open parentheses, r to the n minus 1 power, and then close parentheses divided by r minus 1. And these both can be shown in different fashions. So for this formula, for the arithmetic series, you could actually have Sn equals n over 2, open parentheses, 2u1 plus, open parentheses again, n minus 1, close parentheses, d, close parentheses. And that's a longer way of doing this one right here. This is just a simplified version. And for geometric, you also have a difference, but it's actually very, very minor difference. And that's where on the top and the bottom, the R and the 1 switches place, and on the bottom, the R and the 1 switch places. But however, for geometric, R will never equal 1. Yeah. Okay. So what is a series? Continuing on, let's do the practice for a arithmetic series. And I'm going to be using the longer version just to show you the basics about how to practice or do an arithmetic series. So it says, write an expression for Sn, the sum of the first n terms of the series 64 plus 60 plus 56, and so on and so forth. So they're giving you what Sn is right here, and this is really, really nice. This is out of the Oxford Math SL textbook, and this is really nice how they give this to you, because this just helps you better understand what Sn is, instead of just, inputting values into S, or inputting values into n of Sn and just saying, oh yeah, it's something, but I don't really know what it is. But this is really nice. It's the sum of the first n terms. So let's start with the formula. Sn equals n over 2, open parentheses, 2u1 plus, open parentheses again, n minus 1, close parentheses, d, which is difference, close parentheses. So what we'll have to do first is, like we did whenever we were trying to do sequence problems, we'll identify our first term and our difference. So as you can see, let's start off with the difference, because the difference is a negative, as you can see. The difference is a negative because of the fact that this series is decreasing. This also could possibly be a fraction, but it's left in a whole number like this, and you have u1 equals 64, because that is the first term of the series. Okay, so now we're going to plug in the values. You have Sn equals n over 2, then open parentheses, you keep the 2 that they have right here, you plug in your u1, which is your 64 value, then you add it to n minus 1, because it's just asking for Sn. This is another hint factor again. It's not asking you for a specific term or a specific number. This is the sum of the first n terms. And it's not even giving you the sum of the first 5 terms. They're asking you for the sum of the first n terms. So you leave n where it is. You leave n throughout the board. So you get this as you simplify down. And then finally, with a couple of just basic mathematics, you can get Sn equals 66n minus 2n to the second power. Okay, so this is the geometric series, and it says calculate the sum of the first 12 terms of the series 1 plus 3 plus 9 plus, and so on and so forth. So here you have our formula again, which is Sn equals u1, open parentheses, r to the n minus 1, close parentheses, divided by r minus 1. And remember that this can be changed in the fact that r1 can be in front of r, and then 1 can be in front of r right here as well. But we're just going to stick with the one that I had before, because it's not really that much difference. So remember, again, this is just like an arithmetic series. You want to identify your u1, and that will be 1, because it's the first term of your series. And your r, simple, simple, simple. You can see that it's 3 away. Your ratio is going to be 3, because each step is taking a 3. So then you plug in values with your equation, that you're with the formula that you're given. And what you do is, because it says the first 12 terms and it's not saying the first n terms or the n terms, you need to put 12 in n's position throughout. So you see you have 12 right here because you have it raised to the nth power, but it's actually going to be raised to the 12th power minus 1. And then you can just follow along with your putting in your ratio. You're putting in your first term, and again, you're putting in your ratio minus the -1 already given. And then you'll finally get a number, and then you'll divide that by whatever you got from this, which is 2, and then you'll get 265,720. So that's pretty simple. Sequences and series, remember, a series is a sequence can build a series when it is the sum of the terms of a sequence, and it's just really cool to see how they all connect.